Hello everyone. Previously we had discussed on the topic open close principle and the solid, right? Solid principles basically, right? So today we'll be discussing on the topic Liskov substitution principle, also known as LN solid, right? So LSP basically, right? So let's get into the definition part here. So the Liskov substitution principle LSP, what it states that objects of a subclass should be replaceable with objects of their superclass without affecting the correctness of the program. What it states here again, it states that the objects of a subclass should be replaceable with the objects of the superclass without affecting the correctness of the program, right? So in simple terms, if class B inherits from class A, we should be able to use B wherever A is expected without breaking the system, right? So simple, very simple one. Let's see the same thing with a example, right? So before getting into the example part, so let's discuss some of the points, right? So suppose imagine if we have the parent class, suppose say bird, and the subclass we have sparrow, right? So parent class is bird and the subclass is sparrow. Since sparrow is a bird, we should be able to use the sparrow whenever bird is expected, right? So again, since sparrow is nothing but a bird, we should be able to use the sparrow wherever bird is expected, right? So but if we make the another subclass, right? Suppose we can consider any this thing bird here. So suppose if we make another subclass like penguin that cannot fly, and if our bird class has a fly method, right? So then substituting penguin for the bird breaks the program, right? So because penguin cannot fly, right? So we are making use of another subclass called penguin. Basically penguin cannot fly, and if our bird class has a fly method, then substituting penguin for a bird will break the program, right? So this violates this one, Liskov substitution principle, right? So the principle tells us to design hierarchies properly, right? So in simple terms, LSP, nothing but the Liskov substitution principle, it tells us to design the hierarchies properly, mainly, right? So this sentence we have to just keep this in mind. What does it say? It tells us to design hierarchies properly so subclasses behave consistently with the base class. So subclasses behave consistently with the base class. So this one I found it this one very relevant, and this one I wanted to discuss with you guys, right? So I hope uh, the this one, what do we call, Liskov substitution principle is completely clear, right? So let's see the same thing with very simple example that we discussed recently, right? So let's go with the same example, man. I'll just go with the base class bird here. So let me go with class bird. So this is fine. Next, within the class, let me go with a method or the function make sound here. So this one will be make sound. This is fine. I'll just pass self here. This is fine. Then within this method, every bird can make a sound, right? So I'll just go with print. So let me give here some uh, generic bird sound. So this is fine. Now let me go with one more method here, fly. So I'll just go with df fly, right? So this is fine. I'll just pass self here. So within the fly method, so let's go with a base assumption here, means all birds can fly, right? So for now let's go with all birds can fly. So I'll just come here. So I'll just give here this bird is flying, right? So I'll just come out of this one entirely. Now this is the main class bird, or this is the base class or the main class bird. So now we are done with the main class, so let's go with another class, which is the subclass basically. As we had discussed earlier, let's go with a sparrow itself, bird sparrow. So I'll just go with subclass here. So this will be sparrow of, let me pass bird. This is fine. Now let me make use of uh so subclass, sorry, sub, while telling the subclass I included sub as well, sorry. This one, this is fine. Now let me go with the method make sound. Yeah, this is fine. Now let me delete this one entirely. Along with the self, I don't need anything. Let me print something for the interactiveness. So I'll just go with um, honk honk. Right. So this is fine. Now let me go with one more method named fly. So this one will be fly. Right, so this one let me give here. So this consists of the self as well. Basically this is fine. Penguins cannot fly, we know this one, right? So but base class promise they could, because we are making use of the fly within the base class or the main class bird here, right? So penguins cannot fly here, but the base class promised that they could, right? So by giving here print this bird is flying already within the base class, right? So let's print something here, error. So I'll just go with error just for the interactiveness. So I'll just give here penguins cannot fly, right? So penguin cannot fly. This is fine. So now let's do one thing. Let's use the classes. So I'll just go with def. So this one will be make bird fly. So let me go with the bird. This is fine. This one will be bird as well. So within this method, this function expects any bird and calls the fly, right? So I'll just go with bird dot fly as I've said, right? So I'll just go with bird dot fly. So this is fine. Now we have come to the part where we need to create object. Nothing but we have to test this, right? So let's go with example usage here. Let's create objects. So I'll just go with sparrow. So this one, let me give s here, just the object. So I'll just go with, now let me call sparrow class here. Fine. Next, let me go with penguin. Let me call penguin here. So this one actually I didn't call any how I should be able to call the penguin man. So I did a mistake here. What I did here is I just called this one sparrow. This is fine. So this one let me do one thing, man. So let me copy the same thing here. So I'll just go with, I didn't call the class penguin at all. So let me copy paste here. So this one has to be, so this will give indentation problem. So this is fine. Now instead of this one, I'll just give chirp chirp here. So this is fine. Just the word sound, man. Anything you can give. So I'll just go with class. One more class here. So this one is penguin basically, right? So this one will be bird, right? So I got confused here, sorry. Sparrow, this is only thing, we are just considering make sound here, but we are considering so this sparrow class is there, right? So this follows the this one Liskov substitution principle, or this respects the Liskov substitution principle, right? So we are not going with a fly here, right? So every bird cannot fly, as I have said. Penguins cannot fly, right? So we have considered the subclass again, this one penguin, which basically violates the LSP. So I'll just write this one, I'll just comment this one and write violates this one LSP, or Liskov substitution principle, right? So I have given here class penguin of bird. So def make sound, this is fine. So Hong Kong I have given. So here in the fly I have given correctly, error penguins cannot fly. So I got confused with the sparrow. So I thought I was writing the penguin class and I just went on writing the code. Sorry. Yeah, now this is fine. I have added the penguin class and I've stopped the this one sparrow class here itself. Again, so this is base class bird. This one is base class. We have the methods make, sound, and fly. Right. So this is sparrow class, nothing but the subclass of bird, which follows the, or which respects the this one Liskov substitution principle. Right. So we have another subclass named penguin here. This you can see. Now, why it violates the Liskov substitution principle here? Because penguins cannot fly, but the base class promised they could. Here, see this one, the bird is flying. We have already made use of, this is the base class or the main class, right? So this fails or this violates the Liskov substitution principle. Let's make use of the classes here. So now I can go with the penguin, I guess. So this one will be P, this penguin. So this is fine. Let me delete this one function, right? So this is fine. Now let's do one thing. So we have made use of the class, right? So this is fine. Yeah, this one I'm speaking of. We're just making use of the classes. Means basically this make bird fly, whatever I have written, right? So that function expects any bird and calls the fly method. That's what we are doing here within line number 27, right? So this is fine. Now finally, let's go with the function calls here. So I'll just go with make bird fly. So let me pass sparrow here. This is fine. And again, make bird fly here. Let me pass penguin here. So this is fine. First one, this works fine. This one, make bird fly. This works fine, right? So this is fine. Sparrow is fine accordingly with the Liskov substitution principle or LSP. But this one, this violates Liskov substitution principle, make bird fly of penguin, because as I've said earlier, again I'm stressing on this one. Basically, we have considered the subclass penguin. Basically, penguins cannot fly, but base class promised they could, right? So here, this violates the Liskov substitution principle, right? So the output that we need to get here is this one. What do we call? The bird is flying because we have passed sparrow here. Within the sparrow, we have given here this one. What do we call? We have to get the bird is flying because we are within the make bird fly, we have given bird dot fly. Within the fly, we have given this bird is flying. So we have to get this bird is flying. We are passing this one as well, penguin, right? So this one is nothing but the penguin class. We are calling object here, right? So penguin class, within the penguin, where is penguin? Penguin, this one actually, penguin, yeah. So here we are calling again the fly method, right? So bird fly. So penguins cannot fly. We know that. We have to get the error. Penguins cannot fly. Error, penguins cannot fly. Let's see the same. I'll just go with Python here. Let me copy this one. I paste it over here. .py. So here you can clearly see this bird is flying. Error, penguins cannot fly. We are getting the desired output, right? So basically for sparrow, the function make bird fly, this one. For sparrow, the function make bird fly calls fly, which prints the bird is flying. For penguin, the function calls fly, but since penguin overwrites it incorrectly, it prints error, penguins cannot fly. Basically, this one penguin class subclass violates the LSP or Liskov substitution principle. Uh, this breaks the system's assumption about the bird class, this one subclass penguin basically, right? So when we are making use of that one with the make bird fly method or the function, right? So this is fine. Now we are getting the desired output. Now we know about the this one ln solid principles, right? Nothing but Liskov substitution principle, right? So we are done with the Liskov substitution principle. Now let me summarize whatever we have learned so far, right? So here LSP means subtypes, nothing but the Liskov substitution principle means subtypes must be substitutable for their base types without altering the program correctness, right? So this should be correct. So violation example, what we did there, we made a penguin subclass of bird that cannot fly first, right? So what will be the correct design then? So instead of forcing penguin into the bird with fly, we should restructure the classes. Example, flying bird and non-flying bird, right? So we can just consider in the base class non-flying bird as well, the method or the function non-flying bird as well, instead of directly going with a fly. That we can do, right? So we can just consider flying bird method or the function differently and non-flying bird method or the function differently, just to respect the this one Liskov substitution principle, that we can do. So we are done with ln solid, nothing but Liskov substitution principle. So yeah, we are done with the Liskov substitution principle. Tomorrow we'll be discussing on the topic interface segregation principle, also known as ISP, right? So I in solid. So today we are done with the L and solid. For now, this is it. Thanks for watching, guys.